The second type of problem, same idea. Basically, you want to factor completely and then divide out any common factors. But it's just a different type of factoring. So first, in the numerator, we can factor out the greatest common factor of 4. So that gives us 4 minus x squared. And then our denominator, we're looking for factors of negative 14 that sum up to a negative 5. In this case, we're going to have x minus 7 times x plus 2. In the numerator, this 4 minus x squared is a difference of squares, and that factors to 2 plus x times 2 minus x. So if we bring the denominator down, we look for common factors. X plus 2 and 2 plus x are the same factor. The order of addition does not change any result, so we can divide those out and they cancel, and we're left with 4 times 2 minus x over x minus 7. So when we're simplifying a rational expression, the first thing we want to do is factor completely. So in this problem, the numerator has the greatest common factor of 4, so we can factor 4 out. That will leave us with u squared minus plus 9u plus 8. And the denominator, there's no common factor, but we can go ahead and factor that. We're looking for factors of negative 4 that sum up to negative 3, and that would be u minus 4 times u plus 1. We can continue to factor in the numerator. This trinomial u squared plus 9u plus 8 can be factored to u plus 8 times u plus 1. And the way we got that was we looked for factors of 8 that sum up to 9. So 2 factors of 8, 8 times 1 is 8, and also 8 plus 1 is 9. From here, we just look for common factors to divide. Once we divide the common factors, they cancel out because it goes to 1. So u plus 1 and u plus 1 are common factors. So our final answer would be 4 times u plus 8 over u minus 4. Finally, we're going to look at finding complex solutions of quadratic equations. So this can't be factored. So when you can't factor a quadratic equation, we go ahead and use that quadratic formula. Remember, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In our problem, a equals 3, b equals negative 2, and c equals 1. So we're just going to take each of those values and substitute them into the formula. In the formula, b is negative, so it's going to change the sign of whatever b you have. Since our b is already negative, a double negative turns that to a positive 2 plus or minus square root. So now we're going to have a negative 2 squared minus 4 times a, which is 3, and c, which is 1, all over 2a, which is 2 times 3. So we're going to do some cleaning up here. 2 plus or minus negative 2 squared gives us 4, minus 4 times 3 times 1 is 12. And from here, we'll have 2 plus or minus the square root of negative 8 over 6. So what we're going to look at is we're going to try to simplify this radical, this negative 8, the square root of negative 8. You know you're going to have an imaginary number because anytime you have a negative value under your radical, it yields an imaginary number. So we're going to have to think of 2 factors of negative 8 to where one of them is a perfect square. And it shouldn't be hard to figure that one out. So it's 2 plus or minus. So now it would be negative 4 times 2. So now this is going to give us 2 plus or minus. The square root of negative 4 would give us 2i, and then the 2 would stay home, all over 6. And there's a few different ways to write this final answer. Some go ahead and divide both of the terms on top by 6. Some just simplify. I like to simplify here. We see that 2, 2y, and 6 all have a common factor of 2, so that would leave us with 1 plus or minus I root 2 over 3. So we divided out that common factor of 2. Another thing to remember is that you never simplify what's inside of the radical when you're dividing by a common factor. And then you may have your answer written in another form. Just depends. It can be written as 1 over 3 plus I root 2 over 3, and then also the minus 1 over 3 minus I root 2 over 3. So you basically just take each of these two terms and divide both of them by 3.